So today we are going to do the experimentation part of how to connect two batteries in series connection, how to connect these two batteries in series connection, and how to construct an array of 4 batteries. Okay, let's try to see how we design this fuse rating and everything. Okay, so when you take your experimentation part, you are going to have, this is an 40 Ah battery, this is an 40 Ah battery, it's already printed here. So the rating of this battery is 40 Ah. Okay, so now how many batteries you have? 4 batteries you have. First 2 batteries will connect in series, and next 2 batteries, 1, 2 will connect in series, 3, 4 will connect in series. So the resultant of this will connect in parallel. Therefore, this will construct an array. So just this is similar to batteries or panel, both are same. So group of solar panels is called array. Group of solar batteries is called battery array. Okay, you see this connection diagram. So you see here you have a battery 1 and you have an battery 2 and you have an next set of battery 3 and you have next set of battery 4. This is 1, 2, 3, 4. So you see this negative I joined to positive. Okay, so the negative of the battery I joined to positive. So what are the resultant you are going to get? One is positive and one is negative. So this is one is positive and one is negative. So now what are the ratings of this battery? 40 Ah and 40 Ah. When you connect the batteries in series connection, when you connect the batteries in which connection? Series connection. What is the resultant of these two? Current is constant. Since current is constant, what is the overall capacity of the battery? 40 Ah. Now coming to the second set, battery 3 and 4. This is battery 3, this is battery 4. How we are going to connect the battery? Negative of one terminal is connected to the positive of another terminal. Where is the negative? This is negative and we are connected to the positive of the another terminal. Now what is the rating of this battery? 40 Ah, 40 Ah. We are doing the experimentation part of identical rating of same rating. All batteries of how much rated? Same rated. That's what the benefit of this. Actually we can do with separate rating, but currently we are doing with same rated. This is also 40 Ah, this is also of 40 Ah. Okay, so now you can see here when these two are connected in series, what is the resultant capacity of the battery? 40 Ah. Why it is 40 Ah? These are connected in series. In a series, current is constant. Automatically the capacity is also constant. So this two, when you connect in series, is going to construct 40 Ah. These two are connected in series, this is going to construct 40 Ah. Now what we are going to do? These two positives we are joining, these two negatives we are going to join. This procedure of joining positives and negatives is called as which connection? Now 1, 2 and 3, 4 are connected which connection? Parallel connection. Are connected in parallel. So this is negative of one series panel and this is the negative of another set of panel. So this is the positive of one set of panel and this is the second string. So this is string 1, this is string 2. String 1 and string 2 we are going to call as a group of string is called as an array. Therefore this complete set is called as an array. This is called string 1, this is called string 2. So from string 1 you got one positive, from string 2 you got another positive. We joined that at one positive terminal. Okay. So this is one negative and this is another negative. We joined it here. So string 1 and string 2 are connected in parallel now. Okay. So now resultant you see here. For example, let us take that each battery is of 40 Ah. Let us assume that each are operated for 40 hour. Okay, not 40, let us try to take each is operated for 40 hours. Then how much current you are going to get? 1 ampere current. So but I want 4 amperes current. Then how many hours I have to operate each battery? I have to charge the battery for 10 hours. 10 hours I can charge or 10 hours I can discharge. Then they can supply how much amount of current? 4 amperes. What is the current by the string 1? The string 1 current is constant. How much amperes of current is supplying? 4 amperes. The string 2 is also supplying how much amperes of current? 4 amperes. So 4 amperes current is entering from string 1. 4 amperes current is entering from string 2. The resultant current is how much? 8 amperes. Now we design the safety of fuse and isolator with the help of 8 amperes. Okay, so now 4 plus 4 is how much? 8 multiplied with 1.25 times the maximum current can flow is 10 amperes. So now approximately 10 amperes. You see here we kept safety. How many leads are there? Lead 1 and lead 2. So one lead is of 5 amperes. When you connect two fuses 5 and 5, 5 and 5 in parallel. What is the resultant current? 10 amperes. So this fuse can withstand up to how much current? 10 amperes. We'll also do the experimental maximum loading up to 10 amperes. So in this circuit we used the maximum capacity of how many fuses? First one is basic protection, is called manual KitKat fuse. Next one is advanced protection. Little bit current rated we increased and we are gone for 20 amperes. So this is 10 amperes and 20 amperes. Actually this also you have to use 10 amperes. Since it's not available, we are gone for a little bit higher rating. Okay, so this is manually. So this how it will function is, for example, if any problem occurs in the circuit, automatically this will trip out. So later again we have to close the switch. This is what the mechanism of operation. Okay, let's try to see the procedure. So see your procedure. So now you have a set of array. What are the ultimate set of the array? One positive terminal and negative terminal. So now I want to measure the voltage. I am connecting an voltmeter. So what is the voltage level of this panel? So this battery is of how much voltage? 12 volts. What is the voltage of this battery? 12 volts. So 12 plus 12. What is the resultant voltage at this node? 24 volts and 0 volts. So this is also 12 volts and this is also 12 volts. So resultant voltage is how much? This is 24 volts and 0 volts. Or when you connect these two in parallel, then how much voltage will be generated? So the resultant net output of this array, you are going to get at positive terminal 24 volts, at negative terminal 0 volts. I am going to connect an voltmeter ranging from 0 to 30 volts and type of supply is moving coil type. That's why we connected an voltmeter here, and I want
this is DC current or DC voltages.
Moving coil type. Next, so we connected the voltmeter. Now I want to load it and I want to check it for how much current? 10 amperes. I am going to connect an ammeter, and when the current is entering, this is positive terminal, current is leaving is negative terminal. What is the rating of this ammeter? 0 to 10 amperes I am selecting. Since it is a DC supply, the type of meter I am selecting is moving coil. And now I want to close this positive and negative, and I am going to use to vary the resistance, I am going to use an wire wound coil, which is called a rheostat. So on the leaving terminal I am going to close like this. Okay, you see here this ammeter and rheostat are connected. Which connection? Series connection. Okay, now see this diagram, we can see here. So from here you are getting one positive and negative. This is the output of what? Array of batteries. You got one positive and negative. Resultant positive is this one, resultant negative is this one. Okay, so we directly we want to measure the voltage. We are directly connected the one positive and negative. Voltmeter is connected in parallel. Okay, now we want to close the circuit by using this ammeter and rheostat. Okay, now we take here from positive terminal we had entered to positive of the ammeter. From negative terminal we have been directly entered into the input of the rheostat, and output of the rheostat we are connected to here. Okay, output of the rheostat we closed. Okay, see the circuit diagram is very clear. So the current flows through the ammeter and flows to the rheostat, and the circuit is closed. Okay, now what I have to do? How to start the experiment? So turn on the MCB, which is nothing but miniature circuit breaker. This is designed for 10 amperes, little bit higher rated this is designed, and you can see the voltage values. Okay, everyone start writing the values.
The voltage what you got?
Voltage is 26 into 2.
No.
Sorry, 26 into 1. It's directly connected for 30 volts. 26. I mean 13 open circuit voltage. Okay, it is fully charged. 13 plus 13. How much? 26 volts. So now how much you got? 26 volts. And you can see here current is 0.25 into 1. Write down the current. 0.25 into 1. Next, you see here. So now we have started with minimum current. Let's try to increase the current. I am going with a current of 0.5. So current is, write down, the current is 0.5 into 2. Current is 0.5 into 2 is how much? 1 ampere. And you can see this voltage, this is coming there in the range of 26 into 1. Write down in your notes. Next, I am increasing the current slowly, 0.65. 0.65 into 1. Current is 0.65 into scaling of into 2 Next, write down the voltage. This is again indicating same 26 into 1. Very simple concept. Here you have the base scale 2.5. You have the upper scale 5. How to convert 2.5 into 5 amperes into 2? Here the base scale directly we connected. So that's why 30 is the base scale and we are connected to where? 30. Directly this is nothing but into 1. So you convert them lower scale to upper scale, you have to scale how many times here? 2 times. If you are taking only lower scale, you have to multiply only with 1 time into 1. Okay. Now the current is 0.65. Now let's try to proceed with the next magnitude of current. 0.75 into 2. 0.75 into 2. Write down the voltage. 26 into 1. 26. Next reading. 0.8 into 2. 0.8 into 2. Voltage is same. 26 into 1. Next one. So I am not going longer. Why? Because what is the total capacity now? This is of 40. This is of 40. 40 plus 40. 80 AH. 80 AH means it can supply how much amperes of current? 80 amperes of current in a time of 1 hour. So that's why we should be very careful while we are loading. Current 1 into 2. Already we loaded 2 amperes current. 1 into 2 multiplied with 25 into 1. You can see here as the load is increasing, what is decreasing? Voltage is called voltage regulation. Next ampere current I am going. Write down 1.25. 1.25 into 2. And corresponding voltage is 25 into 1. Next set I am going 1.5 into 2. Voltage is 25 into 1. So I am not going longer. So please make it fast. 2 amperes. 2 into 2 and 24. Okay. So already it's getting overheated. You can see here the coil is fully heated. Okay. You can check it out whether the coil is heated or not. Okay. You check it out whether the coil is heated. Coil is heated, it's fully loaded. Okay, so we should not load it a longer time. We have to bring it into which condition? The original condition. When you bring the US at which position? Maximum resistance, current is minimum and voltage will be higher. Why? Because now it's under which condition? No load condition. Under no load condition, we have more open circuit voltage. Under loaded condition, what will happen? Current is minimum. So now already I explained you these two are connected in series, these two are connected in series. In a series connection, what is constant? Current is constant, 40 amperes and this is also 40 AH. 40 AH and 40 AH again in parallel. So in 40 AH this is a 4 amperes plus 4 amperes. Total current is how much? 8 into total time discharge time is charging time is how much? 10. Resultantly how much ampere current is going to support? 80 ampere hour. So this is how to connect 4 batteries, these 2 batteries in series connection, these 2 batteries in series connection and resultant these 2 are connected in parallel. This is how to understand how to connect the batteries in series connection and parallel connection. We are performing this to design a solar system of higher power rated. Your electric vehicle also will have only 2 batteries and they may have higher current. If you go for higher current, the cross-sectional area of the conductor will be greater. If you go for higher voltage, the cross-sectional area of the conductor will be smaller. So now we have gone for higher area. You can see the cross-sectional area of the conductor is thin. If you use only 1 battery and if you connect 4 batteries in parallel, automatically you have to use 2 square mm or minimum 4 square mm. Why? Because there 12 volts current is how much? 4 into 4, 16 amperes current. Then you have to use minimum 4 square area. Okay. So this is what the advantage. So whether this is advantage or connecting 4 parallel in advantage, it depends upon the system. If you have a 12 volt system and if you want more backup, then you can connect these 4 panels in which connection? Parallel connection. If you want more voltage, then you connect all the panels, all the batteries in which connection? Series connection. Then you get a higher voltage and lower current. or if you want an hybrid, you want more backup, you want an moderate voltage, then you connect these two in series and these two also in series. Resultant voltage is 24 volts, which is indicated in the meter, and depending upon the load, what is going to change? The AH. Okay, now the maximum capacity of this is supplied. This is a good configuration or bad configuration? It's a good configuration. Why? So here you have the required voltage of 24, here you have a required voltage of 24, and it is double backup. So it is supplying 40 Ah for 10 hours. If you want more than 10 hours, we are going to increase the backup with plus 20 hours. Totally how much? So 10 plus 10, totally how much? 20 hours extra backup you are getting. If you want more the backup, better to connect the panels in which connection? Parallel connection. This is called how to connect the solar panel like an array for an increased power rating and increased voltage rating. Hope the experiment is very simple to understand. You can do it of your own now.